The next one is group 16 elements. Group 16 elements is also called as oxygen family because the first element of this group is oxygen. And group 16 elements are also called as chalcogens because they are ore producing in nature. The ores are basically formed with these elements. So oxygen atomic number 8, electronic configuration 1s2, 2s2 and 2p4. Sulfur atomic number 16, electronic configuration valence shell में 3s2 and 3p4. In case of selenium atomic number 34, the electronic configuration of valence shell is 4s2 and 4p4. In case of the tellurium, the atomic number 52, the electronic configuration of valence shell is 5s2 and 5p4. And polonium, which is radioactive in nature, atomic number 84, its electronic configuration of valence shell is 6s2 and 6p4. So the general electronic configuration of p block element is that all of these are having noble gas configuration. After that, all of these are having s2 and p4. The difference is only this valence shell or number. So in this case, this is 2 2, here is 3 3 4 4, so we can use the ns2 and np4. This is the general electronic configuration of the group 16 elements. The noble gas in this case, it is our helium. After that, in case of the sulfur, the noble gas is neon. In case of selenium, noble gas is argon. So in case of the tellurium, the noble gas is xenon, and in case of polonium, the noble gas is radon. Next one is the metallic character. So the first two elements of this group is non-metal, oxygen and sulfur. The another two elements, that is selenium and tellurium, are metalloids, which is having the characters of both metals and non-metals. And the last element, which is radioactive, it is having only metallic character. And it is well known that the oxide and hydroxide of the metals are acidic in nature. The hydroxide and oxides of the metalloids are amphoteric in nature, and the hydroxide and oxide of the metals are basic in nature. Next one is the oxidation state. As we know very well that all the p block elements show the two types of the oxidation states. The first oxidation state is also called as group oxidation state. Group oxidation state formed when all the valence electrons are removed, and 2 unit less oxidation state is the 2 number less than the group oxidation state. So in case of the oxygen atomic number 8, the electronic configuration is 1s2, 2s2 and 2p4. So in this case, the valence electron is 6. So here the group oxidation state is 6. In case of oxygen, sulfur, selenium, tellurium, the group oxidation state is plus 6. And the 2 unit less oxidation state is plus 4. The group oxidation state of the 2 unit less oxidation state of the sulfur is also plus 4. 2 unit less oxidation state of selenium is also plus 4, and finally the tellurium is also plus 4. We exclude the polonium because it is the radioactive. The last element is polonium, we know very well. And in the last element, the 2 unit less oxidation state is more stable, and except these, the group oxidation state is more stable. So in case of oxygen, say sulfur, selenium and tellurium, this group oxidation state is more stable as compared to 2 unit less oxidation state. Or I can say the sulfur plus 6 is more stable as compared to the sulfur plus 4. It is comparatively less stable. Or I can say that is SF6 is more stable as compared to SF4. The first question is that why SF6 is more stable than SF4. Sulfur hexafluoride is more stable than sulfur tetrafluoride. In SF6, the oxidation state of sulfur is plus 6, that is group oxidation state, and in SF4, the oxidation state of sulfur is plus 4. So we know that very well. In case of sulfur, the group oxidation state is more stable as compared to 2 unit less oxidation state. It is due to the inert pair effect. Inert pair effect we have already discussed in the group number 15. The next question is that SF6 exists but OF6 do not exist. The electronic configuration of O is 1s2, 2s2 and 2p6, and we know that 2d orbitals do not exist. The d orbital starts from the n is equal to 3. So in oxygen, the 2s subshells having 2 electrons and 2p subshells having 4 electrons. So there are only 2 half-filled atomic orbitals in which the fluorine can be attached. So due to the absence of the 2d orbitals, the electron cannot promote from 2p to 2d. In case of sulfur, the 3s subshells having 2 electrons, 3p subshells having 4 electrons, and 3d subshells is empty. So after the promotion of electron from 3s to 3p to 3d and from 3s to 3d, the valency of the sulfur extend from 2 to 6. So in case of 3s, there will be 1 electron, In case of 3p, there will be 3 electron because 1 electron is promoted here. And in 3d orbital or in 3d subshells, there are 2 electrons after the promotions. So we are having the 6 half-filled orbitals in which the sulfur can attach. So SF6 can exist. The next question is that SF6 exists but SH6 do not exist. In both this case, the valency of sulfur is 6, and we know that the 6 valency of sulfur is possible. Fluorine is more electronegative than sulfur. It can easily promote electron from 3s and 3p to 3d and can extend valency from 2 to 6. The electronegativity of hydrogen is very less as compared to sulfur. So hydrogen is not able to promote the electron from 3s and 3p to 3d. So in this case, the valency cannot be extended. So SH6 do not exist.